Hello everyone, myself Apurva, and today we are going to be discussing about automata theory and compiler designs. The main topics under this subject that we are going to be discussing in this video are DFA, NFA, and how to convert an NFA into a DFA. So first, let us see what is a DFA. DFA also is called as deterministic finite automata. It is a fundamental concept in computer science with various applications in areas such as programming languages, compilers, and natural language processing. DFA is a mathematical model that represents a finite set of states and transition between those states based on the inputs given. It is used to recognize and process regular languages, which are a subset of formal languages. On each input symbol, there is only one state to which the machine will be changing from its current state. The DFA consists of mainly five states. The first one is a finite set of symbols, which is denoted by the summation. And then we have a finite set of states that is denoted by capital Q, and a transition function, a start state, which is the starting state of a DFA denoted by the Q naught, and the final state, which is the last state or the final state where the whole DFA ends, which is denoted by the capital letter F. And therefore, we can write it as A is equal to Q, comma sigma, comma transition, comma Q naught, comma F. This is about DFA. Now, what is an NFA? NFA stands for non-deterministic finite automata. It is easier to construct compared to the DFA for any given regular languages. The finite automata are called NFA when there exist many paths for a specific input from the current state to the next state. Every NFA is not a DFA, but each NFA can be converted or translated into a DFA. NFA is defined in the same way as a DFA, but with the following two exceptions. It contains multiple states and it contains an epsilon transition. NFA also has five states similar to the DFA, but with different transition function as follows. That is a finite set of symbols, which is denoted by sigma or the summation symbol, a finite set of states, capital Q, the transition function, the start state, and the final state. Now, this is also denoted in the same way as Q and a sigma transition function Q naught and F. Next, now here we have been given a question where we have to convert the given NFA to a DFA. So now first let us write the transition table for the above NFA. In the transition table, we are going to be writing the states and for each state on giving A and B to which other states the transition is taking place. So the first state is Q naught and we have given arrow mark next to Q naught because it is the starting state, and so Q naught on giving A, it is going to only Q naught, and on giving B, it is going to Q naught, comma Q and Q1. And for the next state Q1, on giving A, it is not going anywhere, so it is going to be denoted as null. And on giving B, it is going to Q2. And Q2, the next state is Q2, and next to Q2, we have given a star symbol because that's the final state of the given NFA. So Q2 on giving A, it is not going anywhere. There is no transition taking place. So that will be null. And similarly, Q2 is not transited anywhere while given B as the input. That is also taken as null. So now moving on to the steps to convert a given NFA to DFA, the first step will be identifying the start state of the DFA. As in the diagram, we can see that the starting state of the NFA is Q naught. So because of that reason, the starting state of the DFA also will be Q naught. Now step 2 is identifying the alphabets for the DFA, and that will be A, comma B. Now step 3, we are going to be considering each state and check the transition function for each state, considering A and B. So first we are going to check the transition function of Q naught for A, which will be Q naught, and for B it will be Q naught, comma Q1. Now we cannot consider Q naught as a new state because it was already present as the initial state of the DFA. So hence we are going to be considering Q naught comma Q1 as the new state. Now we are going to be considering Q naught comma Q1 and we are going to be doing the transition function on that. We Next, the transition function of Q naught comma Q1 on A will be Q naught and on B it is Q naught, Q1 and Q2. That will be a new state as Q naught is already present. And next we are going to be doing the transition function for Q naught, Q1 and Q2. On doing the transition function for Q naught, Q1 and Q2 on A, we are again getting Q naught, and for B we are getting again Q naught, Q1 and Q2. Now here as we can see that all the states are repeating and there are no new states forming. Now as we have seen in the before slides that all the states are repeating and there are no new states being formed. Hence now we are going to be writing the DFA. And after writing the DFA as shown in the figure, now we are going to be writing the transition table for the above DFA, where the states are Q0, Q0, comma Q1 and Q2. And Q0 on giving A, it is going to Q0, and on giving B, it is going to Q0, comma Q1. And Q0, comma Q1 on giving A, it is null, and on giving B, it is going to Q2. And Q2 on giving A, it is again not going anywhere, it is null. And B, it is also not going anywhere, so it will be null. So now this in the states, in the transition table in the states, we have here taken an arrow mark next to Q naught, which depicts the starting state or the initial state of the DFA. And next to Q2, we have made a star symbol, which denotes the final state of the DFA. Now in the above diagram, as we can see that Q naught is not taking any it is not moving further towards A or B. It is not getting transisted anywhere. So in the above diagram, Q naught will be a dead state. And thank you. That's it for today's video.